Okay, so this is the higher predicted paper, and again, in terms of predicted paper, this is the mock that Edexcel released. So it's probably the best guess of what is going to be on the actual paper, and certainly the style in which it's going to be written. Now, the first one is a fairly standard subtraction of mixed numbers question, so this is not a bad one to get you going. So when we do something like this, 2 3/5 minus 1 5/6, the first thing we've got to do is we've got to put it into mixed. So we've got to put it into top-heavy fractions. There is a RescorlaMaths video on that if you want to have more information on it. But what we do is we do 2 lots of 5, then we add the 3. So that's going to be, it's not going to be 8 at all, is it? It's going to be 13 over 5 minus 11 over 6. Now, another way of thinking about that is if you've got 2 whole pizzas and then 3/5 of a pizza, we're saying that each pizza is going to have 5 slices. So we've got 2 whole pizzas, and then we've got another 3/5 of a pizza, so another 3 slices. So in each whole pizza, it's going to be 5 slices. 10 slices plus another 3 is going to be 13, which is where we get this 13 from. And then the bottom number stays the same. So if we've got this number here, 1 5/6, that's going to be 1 whole pizza, and this time it's got 6 slices. And then we've got another pizza, and that one's only got the 5 slices. So that's going to be 6 slices in this one, plus another 5 is 11. So that's where we get these numbers from here. Now, when you add or subtract a fraction, you've got to make sure that you've got the same denominator. So what we do is we start off with the bottom left, so bottom right, and we go 6 lots of 13 and 6 lots of 5. 6 lots of 13 is 78, 6 lots of 5 is 30. Then we do the same with the bottom left, so we do 5 lots of 11, 5 lots of 6. That makes 55 over 30. And 78 take away 55 leaves us with 23 over 30. And that's the first 3 marks. Okay, so then if we move on to the next question, what we've got here is we've got, if we clear the screen, we've got a conversion graph, and this converts phone calls in minutes, so X is minutes, and the Y-axis is the cost. Now the first 2 questions here say give an interpretation of the intercept and give an interpretation of the gradient. Now what the interpretation means is what it actually means. What does the intercept mean? So the intercept is where it goes through the y-axis, but what does it mean in the context of this question? So the x-axis we said was minutes. So this is 0 minutes, and that's going to be 0.5 pounds. So that's going to be the cost of making the money. So that's going to be the initial cost of the call. Interpretation of the gradient, that means the gradient, another way of thinking about the gradient is every 1 you go over on the x-axis, that's how much you go up on the y-axis. So that means for every extra minute, we go up by whatever the gradient is. So this is the cost per extra minute of the call. And now part 3 says, find the equation of the straight line in the form y equals mx plus c. So if we've got y equals mx plus c, that's the equation of any straight line. Now this m is the gradient and this c is the intercept. So if we go up to here, we've got to find out what y equals mx plus c is. Now the easy one is going to be this plus c, because this is where it goes through the y-axis. And we can see here that it goes through at 0.5. The slightly trickier bit is finding the gradient. Now the gradient is every 1 it goes over, it goes up by this much. So we can see that it goes up from 2 to 3.5. So that's a rise there of 1.5. It's going to be y equals 1.5x plus 0.5. And that's what the equation of the line is. Another way of working out the gradient is we take any 2 points that lie on the line. So let's take this point here and this point here. And it's going to be the change in height divided by the change horizontally. So here we can see we've gone across from 1 to 3, so we've gone across by 2. And here we've gone up by 3, so we've gone up from 2 up to 5, so that's a height of 3. So the gradient is 3 over 2. And if you do 3 divided by 2, you get 1.5. So either way of finding the gradients, that's what you need to do. Then we put it in here. Remember, any straight line is y equals something x, and that something is the gradient, plus this something here, which is the intercept. Okay, the next thing we've got to do is we've got to work out the area of A, B, C, D, E. Now this is a slightly trickier question. And the way we do this usually is we just separate this into a rectangle and then a triangle. However, once we do, if we start this question off, we've got 8 times 4, so we've got 32 centimeters squared. That's just by doing the area of a rectangle. That's reasonably straightforward. We're going to get 1 mark for that. However, we've got the base here, which is 8, but we don't know what the height of this rectangle, so what the height of this triangle is. So that's what makes the question trickier. However, if we break it down the way we have done here, we've got 5 centimeters going across, and we know this is 8 centimeters going all the way across here. So this bit here is going to be 4 centimeters, but we don't know what the height is. However, we've now got a right angle triangle, so it's a matter of being able to spot, and this is Pythagoras. We've got 2 sides of a right angle triangle, and we're looking for the third one. So Pythagoras is a squared plus b squared equals c squared. So that's going to be a, b, and c. So a squared is going to be 4 squared. B squared we don't know, so we're going to leave that as b squared. And c squared is going to be 5 squared. So if we work that out, that's going to be 16 plus b squared equals 25. If we take away the 16 from both sides, b squared equals 9. So b equals 3. So remember b, what we're working at here, that's the height of the triangle. So now we've got the height of the triangle. And then we've got to work out the area of this triangle. So the area of a triangle is base times by height divided by 2. So it's going to be 8 times by 3 divided by 2. So 8 times by 3 is 24. Divided by 2 is going to be 12. So that's going to be 12 centimeters squared for this whole triangle here. So we've got this shape, we've got this shape. So it's going to be in total 44 centimeters squared. Now, most people that sit the higher paper can do Pythagoras, but here it's a matter of spotting that you need to use Pythagoras, and that's where the hardest bit's going to be, and that's why this paper's harder this year than it's ever been in the past. Okay, distance, speed, and time questions. I've done a lot of these with my Year 9 and Year 10 recently, and the one thing I say about distance, speeds questions is just write down the information that you know first of all. And if you've ever got an average speed, 110 miles per hour, what you do is you write down that's going to be 110 miles in 1 hour, or 60 minutes. So here we've got Terex train leaving Manchester at 8:35, and it got to London at 11:05. So that's taken 1 hour and, no sorry, it's taken 2 hours and 30 minutes. So that journey took 2 hours and 30 minutes. And we know that it travelled at 110 miles per hour. So if it travels 110 miles in 1 hour, in 2 hours, that's going to be 220 miles. And in half an hour, that's going to be 55 miles. So in 2.5 hours, that's going to be 275 miles. Now what that does, it tells us the distance from London to Manchester. So on Wednesday, Jill travels by train from Manchester to London. It leaves at 8:35, but was diverted. The train had an extra 37 miles. So if the journey was 275, it's now an extra 37 miles. If we add that together, so 275 plus 37, it's going to be 2, carry the 1, 1, 3. That's going to be 312 miles. And the train got there at 11:35. So if it leaves at 8:35 and gets there at 11:35, count on the fingers, 9:35, 10:35, 11:35. That's going to be 3 hours. And what we've got to do is we've got to work out the difference in the average speed. So to work out the average speed of the train, of Jill's train, we know that it goes 3 hours and it travels 312 miles. So if it's 3 hours and 312 miles in 1 hour, if we divide that by 3, divide 312 by 3. Again, we've got to be used to just doing this quickly. So 3's into 3 go once, 3's into 1 don't go. That's 0 and we carry the 1 across. 3's into 12 go 4 times. That's going to be 104 miles in 1 hour. So therefore her average speed is 104 miles per hour. And we know that Tarek's train is 110 miles per hour. So the difference in speed there is going to be 6 miles per hour. You might want to do 110, take away 104, just so that you show that you're doing the workings. Yeah, that's the answer for that one. Okay, moving on, and that's worth 4 marks, and it's not an easy question right at the start. Okay. Now I've seen a couple of these questions, which sort of leads me to suspect that this sort of question will definitely come up. I think it's likely to come up. So what we've got here is Frank is going to cover the wall with rectangular tiles. Each tile is 60 by 30. So all we need to know is how many tiles we're going to fit into this one. And there's a few ways of doing it. We can say that 1.8 meters is 180 centimeters. So if we line up them as 60 centimeters down like that, that's going to be 3 tiles, which means this is going to be 30 centimeters going across. It's going to be 3 tiles going down, and then all the way across we've got 30 centimeters, 30 centimeters, and how many times does 30 centimeters go to make 6 meters? Well, 10 lots of that will be 300 centimeters, which is 3 meters. So therefore it's going to be 20 lots of 30 centimeters to make 6 meters. It's going to be 20 going across. So therefore, if we've got 20 tiles going across and 3 tiles going down each time, that's going to leave us 20 lots of 3, which is going to be 60 tiles. Now I'm told that 3/5 of these tiles are going to be white. So to work out 3/5 of 60, 1/5 of 60, we just divide by 5. So that's going to be 12 tiles. However, we want 3/5. So 3/5 of 60 is going to be 36 tiles. So we now know that we're going to have 36 white tiles, which means that the other colours are going to be, which means the other tiles are going to be 24 tiles. So we're going to have 24 tiles, and we're told here that they're being split down to the ratio 1 to 3. So we've got to split 24 into the ratio 1 part to 3 parts. So 1 part to 3 part gives us 4 parts. So we're going to split 24 tiles down into 4 parts. So if 24 tiles are 4 parts, 1 part equals 6 tiles. So that's going to be this one here, and then 3 parts is going to be 3 lots of that, so it's going to be 18 tiles. So all we need to do is we need to write down which one's which. So we know that the white tiles equals 36. We know that the green is the first part of this, so the green is going to be 1 part, which we worked out was 6 tiles. And then the other colour was blue, so 3 parts. So blue equals 18 tiles. Once you've done your workings, make sure you make your answer clear. Don't make the examiners go and hunt around for it. Always try and make your answers as clear as possible. Oh, next one. Frank is told that he should leave gaps between the tiles. So if Frank leaves gaps between the tiles, how can this affect the number of tiles that he needs? Well, if he has gaps in between his tiles, there's going to be less space for the tiles to go on. So therefore, he may need less tiles. It doesn't say to justify, it just says how could this affect the number of tiles. So he may need less tiles, should be enough to get you the answer. Okay, so let's make this one a smidge smaller. So on Monday, Ria delivered the parcel to a hospital. The travel graph represents Ria's journey to the hospital. So Ria left home at 1300. So she left home at 1 o'clock. So let's put 1300 there. She drove for 30 minutes at a constant speed of 40 miles an hour. Then she stops for a break. So therefore, that's going to be half an hour there. So that's going to be 1330. So now what we can do is do the rest of the axes. So that's going to be 1400. 1430. 1500. 1530. 1600. 1630. 1700 or 5 o'clock. Right, now she drove at 30 minutes for a constant speed of 40 miles an hour. Now 40 miles an hour, again, if it's distance time, I'd say 40 miles an hour means 40 miles in 1 hour. So if you're going to go 40 miles in 1 hour, if she travelled for 30 minutes, which is half an hour, that's going to be 20 miles. So therefore, this is when she stops. That must be 20 miles. Therefore, that must be 10 miles, 30 miles, 40 miles, and then obviously 5s in between. So once we've got the axes sorted, these questions tend to be a little bit easier. So let's go back to the question. She left home at 1 o'clock, or 1300. She then drove for 30 minutes, which we can see. She then, at a constant speed of 40 miles an hour, which we've worked out. She then stopped for a break, and she stopped for a break because it's gone horizontally. She then drove to the hospital at a constant speed. She was going to the hospital for 30 minutes, so therefore she's going to stay there for 30 minutes. So again, when you stay at a certain place, it's going to go flat. So she's going to stay at 30 minutes, which we know is going to be from 3 o'clock to 3:30. She then drove home at constant speed of 32 miles an hour. Show that she does not arrive home before 16:30. So 32 miles an hour, that means 32 miles in 1 hour. So if you have a look here, she's got to travel 40 miles. So I've got to go from 32 miles to 40 miles. And I need to see how long that's going to be. So I need to find something that goes into 32 miles and also into 40 miles. And I know that 8 miles goes into both of them. So to get from 32 miles to 8 miles, I need to divide that by 4. So if I divide the time by 4, that's going to be a quarter of an hour. So therefore, 40 miles are going to be 5 lots of that. So that's going to be 5 lots of a quarter of an hour. Or you just add these two together. And that's going to be 1 1/4 hours. So therefore, she's going to take 1 1/4 hours to get home. So she leaves at 3:30 and it takes her 1 1/4 hours. That's going to be 16:45, which is here. If we then join that back, we can see that that is after 4:30. Okay, so let's have a look at the next question. Now the key word in this question here, if we zoom in, is work out an estimate for the value of that. So when you work out an estimate, what you do is you take the first number of all of them and you round it to that size. So the first digit in the first number is in the tens. So you round it to the nearest 10, so that's going to be 40. Next one, you round it to the nearest 10, so that's going to be 100. And the first digit here is tenth, so you round to the nearest tenth, or 1 decimal place, and that's going to be 0.2. And that's going to get you the first mark. So the next thing you do is you actually work out the top. So the square root of 100 is 10, so 40 times 10 is going to be 400. Divided by 0.2 gets you the second mark. And then you've got to be able to divide using decimals. So when you divide using decimals, I don't bother doing it. I just times the top and the bottom by 10. So that's going to give us 4,000 divided by 2, which is 2,000. Now we don't need to do anything to the answer. The answer is simply 2,000 for that one. So you don't need to divide by 10, because when on this stage here, if you divide the top and the bottom, so if you times the top and the bottom by the same number, it is exactly the same fraction. Okay, so let's have a look at the next question, which is translations, but it's translations using vectors. Now, if you think this one here, you've got a shape A. So let's say shape A looks like this. And we're going to translate it using 4, 7. That means we're going to move it 4 to the right and then 7 down. And then we're going to translate it 3 to the left, then 2 down. So 3 to the left and then 2 down. So we've got to describe the single transformation that takes A, which is this one, onto C, which is this one down here. So if we have a look, first of all, we moved it 4 to the right, and then we moved it 3 to the left. So in total, that's moving it 1 to the right. Initially, we moved it 7 down, then we're going to move it 2 down. So that's going down by 9, so that's going to be -9. And as long as you know that vectors need to be written like this, then that's absolutely fine. Be careful, don't write 1 over -9, because as soon as you do that, you've made it a fraction, and that's incorrect. It's got to look like this one here. Next, question 9. So it's a wordy question, so just take your time on wordy questions. Make sure you read it carefully, read it over and over again, just to see what it looks like, and see what it's saying to you. So a company orders a number of bottles from a factory. The 8 machines in the factory can make all the bottles in 5 days. All the machines work at the same rate. So for 2 days, only 4 machines are used to make the bottles. From the 3rd day, all 8 machines are used to make the bottles. Work out the total number of days taken to make all the bottles. So again, what you need to do is you need to go back and you need to sort of underline key things. So 8 machines in the factory can make all the bottles in 5 days. So that means if 8 machines are going to take 5 days, 1 machine would take 40 days. So it's 40 days worth of work that we need doing here. So for 2 days, only 4 machines are used to make the bottles. So then if you move on to the next bit, we've got for 2 days, only 4 machines are making the bottles. So we've got 40 days worth of work that needs doing. And so we've got 4 machines doing 2 days work. So that's going to be 8 days. So that's 8 days work that's done. So therefore, if there's 40 days worth of work that needs doing and 8 days have been done because you've got 4 machines for 2 days, then you're going to be left with 32 days work. So if you've got 32 days work and you've got 8 machines, then 8 machines doing a day's work each, and you've got 32 days worth of work. If you divide that by 8, then these 8 machines are going to be working for 4 days. So here we've got 2 days where 4 machines are doing the work, then you've got another 4 days, so in total that's going to be 6 days. So that's the answer for this one. It's going to take 6 days to do all the bottles. Okay, so next up, question 10. So what we've got here is we've got negative powers, and we've also got fractional powers as well. So the first thing I'm going to deal with is the negative part of it. So if we've got 64 to the power of -2/3, the first thing I'm going to do is get rid of the negative bit. So we're going to write 1 over 64 to the power of 2/3. So 1 over 64 to the power of 2/3, what we need to do is we need to work out what 64 to the power of 2/3 is. Now the way we deal with fractional powers is the bottom of the fraction, that's the root. So we're going to do the cube root of 64. And then the top is the power that we raise it to. So once we've got that answer, we're going to square it. So the cube root of 64 means something times something times something makes 64. So we could try 3 times 3, which is 9 times 3 is 27. No, it's not going to be that. We could try 4 times 4 times 4. 4 times 4 is 16, times by 4 is 64. So the cube root of 64 is 4. Then we're going to square that. So 4 squared equals 16. So 64 to the power of 2/3 is 16. So going back to this question here, it's going to be 1 over 16. And that's the answer for this one. So step 1, deal with the negative power. You do 1 over, and then make it a positive power. We've then got to work out what 64 to the power of 2/3 is. So we do the cube root. So the cube root of 64 is 4. Then we raise it to the top of the fraction, which is squared. So that's going to be 4 squared, which equals 16. Okay, let's have a look at the next question, question 11. So if we just make this a touch smaller. So what we've got to do here is we've got to match each cumulative frequency to its box plot. So, Jo measured the heights of students in 4 different classes. She drew a cumulative frequency and box plot for each. So what we're going to do, I think the easiest thing to do is we find the median first of all. So the median is halfway. So if we go across, the median for A is going to be here. So that's going to be 160. The median for B is going to be there, which looks like 150. The median for C is going to be here, which is 170. And then we've got the median here, which is going to be 160 again. So hopefully this one and this one should be relatively straightforward. So here we got, and this is 170. So that was C. So this one here is C. We've got 150 for B. So that's this one here. So if we write it over here, we got Z, which is C. We got 150 for B. So 150. Oh, in fact, it's not 150, is it? It's over 150, about 155. So that's going to be this one here. So X is B. And then we've got the other two, which have got a median at 160. So we have a look at, apologies, that was the bell. So we've done B and C. So now what we've got to look at are A and D, which have got the same median, which is 160. So what we're going to do is we're going to have a look and see the interquartile range. Now to work out the median, sorry, we got halfway, so a quarter of the way, and 3/4 of the way. That would be the interquartile range. So this here would be the interquartile range. If we do the same for D, we see the difference between A and D. D has got a far bigger interquartile range, and C has got a far smaller interquartile range. So the two that we've got left, W and Y, both with medians here, we can see that this one has got a far bigger interquartile range, so therefore W must be D, and this one here has got a far smaller interquartile range. Sorry, Y has got a far smaller interquartile range, so Y must equal A. Hopefully that made sense. That might not be the best explanation I've ever given, because going up and down on the graph there. Okay, but hopefully, if we then take that down to this here, we've got A, which is Y, so Y goes there, B, which is X, C, which was Z, and D, which was W. Okay, so moving on. We can make it a little bit bigger again there. So in a sale, the price of a jacket is reduced. The jacket has a normal price of £52. The jacket has a sale price of £41.60. We've got to work out the percentage reduction. Now, the way you work out percentage reduction, that's the actual reduction divided by the original, and then multiplied by 100. So the actual reduction is the difference between £41.60 and £52, and that's going to be £10.40, divided by the original, which is £52, and we times by 100. Now, if we had a calculator, this would be dead easy. Unfortunately, we don't, so we've got to somehow do £10.40 divided by 52. So £10.40 divided by 52, let's try and work that out as a different fraction. That makes it a little bit easier to deal with. If we times top and bottom by 10, because we've got a decimal, 104 over 520. And now let's divide through by 2. So that's going to be 52 divided by 260. Divide through by 2 again. That's going to be 26 over 130. Divide through by 2 again. That's going to be 13 over 65. And we can't divide through by 2 again, but we should be able to see that 13 goes into the top and the bottom. So 13 goes into the top once, and it goes into the bottom 5 times. So we've got a fifth times 100. Now a fifth of 100 is 20. So it's going to be 20%. Now this was worth 3 marks for this one. And the first one is going to be for actually knowing what percentage reduction is. So if you do know how to do percentage reduction or percentage increase like this, then this is going to give you the 1 mark. And then it's trying to actually work it out to get the 2nd mark, and getting your final answer is going to be your 3rd mark. Okay, so now this one has come up a bunch recently, and again I've got a real strong feeling that this one will be in the exam. So we've got to prove algebraically that the difference between any 2 different odd numbers is an even number. So first of all, on all these questions, what we do is we start off with our first number. So let's call our first number x. So let's say x was 7. The next number, 8, would be x plus 1. That's not the next odd number. The next odd number would be 9, which from this one you've got to add 2 to it. So that's going to be x plus 2. And that would work even if you chose another odd number. Let's say you chose 97. X plus 1 would be 98. That's the next number. But then the next odd number would be 99. So if this is any odd number, this is going to be the next odd number. And what we've got to do is prove that the difference between these 2 odd numbers is even. So the way you work out the difference between 99 and 97 is you do 99 take away 97. So it's going to be x plus 2, and then you take away x. So x plus 2 take away x equals 2. And that would be if they were consecutive. But what we've got now is we've got any 2 different odd numbers. So an odd number is going to be, let's say an odd number will be any number. It could be odd or even. And what you've got to do to make it odd is you double it, and then that's definitely going to be an even number. So 2x is going to be an even number, plus 1, that's going to be another odd number. So 2x plus 1 will always give you an odd number. Okay, let's do another odd number. So let's choose the number y, and that could be an even or an odd number. If we times it by 2, that's going to be an even number. Then you're going to add 1, and then that's going to definitely be an odd number. So what we're now going to do is we're going to do the difference between these two odd numbers is we're going to do one of them take away the other one. So if we do 2x plus 1 take away, so if you do that in bracket, 2x plus 1 take away 2y plus 1, we're going to do 2x take away 2y, so that's just going to be 2x take away 2y. If we do 1 take away 1, that's just going to be 0. So the difference between 2 odd numbers is going to be 2x minus 2y. And the way we show that that is going to be an even number is we show that it's in the 2 times table. So then we can then say that's going to be 2 lots of x minus y. Now it doesn't matter what x minus y is, that's going to be any number, but when you times it by 2, it's going to make it an even number. So we then need to say that 2 times by any number, i.e. x minus y, is even. Again, not straightforward, but it's not going to be straightforward because we're now getting to the midpoint of the paper, and we all know these papers are getting harder. Okay, but saying even though it is getting harder, they do chuck in questions like this, which, if you've learned how to do this skill, it's not too bad. So what we've got here is a recurring fraction, so a recurring decimal, and we've got to write it as a fraction. So the first thing we do in all these cases is we write x equals, and then write this out. So 0.624, and then what we're going to do is we're going to do the recurring bit. So the dots are above the 2 and the 4, so that everything between the 2 and the 4 gets continued. So in this case, it's just 2, 4, 2, 4, 2, 4, and that goes off forever. Now what we're going to do is we're going to times it by 10. So 10x equals 6, and you try and make the decimal points in the same place. So 2, 4, 2, 4, 2, 4, 2, 4, and that goes on forever. That's no use to us because the 2's and the 4's are not lined up. So what we do is we times it by 10 again to get 100x. So if we times 10x by 10, that's going to be 62.424242424242, and that goes on forever. Now, let's get rid of this 10x. Haven't done that brilliantly, but what we now see is that the 2's as the second place line up, the 4's line up, the 2's line up, the 4's line up, the 2, and so on forever. So now what we're going to do is we're going to do this one, take away this one. So it's going to be 100x, take away x, and 62.4, take away 0.6. So we're going to do this one, take away this one. 100x take away x is going to be 99x. 62.4 take away 0.6 equals 61.8. And then we divide by 99. So we've got 61.8 divided by 99. And again, we've got decimal points in our fraction. So just like we have done a couple of times so far this paper, we're going to times top and bottom by 10. So 618 divided by 99. So 990, because we've times top and bottom by 10. I would then divide by 2. So that's going to be 309 divided by 495. And we're going to try and put it in its simplest form. Now, I can see that 3, so if I add the top up, that's going to be 12. And I know 3 goes into 12. If I add the bottom digits up, 4 plus 9 plus 5 is 18. So I know that 3 goes into 18. So I should be able to divide the top and the bottom by 3. So if I divide the top by 3, I'm going to get 103. I divide the bottom by 3. 495 divided by 3. 3's into 4 go once, with 1 left over. 3's into 19 go 6, with 1 left over. 3's into 15 go 5 times. That's going to be 103 over 165. Now again, fantastic if you can get this, and if you can simplify this down to this one here. But if not, the key thing for these questions, if you've got to do a recurring decimal as a fraction, what you do is step 1, you write it as x equals, and then you write it out in full, well, full-ish. You then write out 10x, so that was 6.24, and you do that again for 100x, and you see whether or not the numbers line up. Once they line up, you do the second one that lines up, take away the first one that lines up. And that gave us this thing here, which if you then divide by 99 gives you this thing. And as soon as you got that, that's going to be your second mark. And your third mark is actually getting the final answer. Okay, next question, question 15. Okay, next question, and this one isn't easy. But what you've got here is you've got a curve, and you can tell it's an x squared curve because all x squared curves do this. And the first thing we're going to do is we're going to figure out where it goes through the x-axis. Now, on every time a curve or line goes through the x-axis, we know that it's something across but then 0 up. So we know that the y-coordinate here is going to be 0, just like it is there. So what we're going to do is we're going to write out y equals x squared over 10 minus 3x, but we're going to make the y-coordinate 0. And now we're going to work out what value of x makes the y-coordinate 0. So we're going to bring this over to the other side. So we get 3x equals x squared divided by 10. We're going to times by 10, so we're going to get 30x equals x squared. In fact, what we're going to do is we're going to bring that 30x back over. So 0 equals x squared minus 30x. And now we've got to see what makes this 0. So if ever we've got an x squared and an x equation, and that equals 0, what we're going to do is we're going to factorize out the x. So x times by x minus 30 equals 0. So what we've got here is we've got this number times by this thing makes 0. Therefore, we've got to find two values of x that when you multiply them together make 0. So either this thing's going to be 0, so we're going to have x equals 0, we're going to have this bracket equals 0. So if you substitute, say, 10 into that bracket, you'd have 10 take away 30, that's going to be minus 20. What we've got to do is we've got to somehow find a number that when we substitute it into this bracket here, we make 0. So we're going to have x equals 30. So therefore we know that here we've got x equals 0, here we've got x equals 30. Now it says find the depth of the bowl. So the depth of the bowl is this point here, which is going to be halfway. So if halfway between 0 and 30 is going to be 15. So when x equals, so this coordinate here is when x equals 15, we're going to find out what y is. So just like in a regular graph, if you had y equals 3x plus 2, and I told you that x was 7, to work out what y is, we do 3 lots of 7 plus 2. So here, on this graph, on this curve here, if you're told that x is 15, y is going to be whatever you get when you substitute 15 in. So, we're going to do 15 squared divided by 10, take away 3 lots of 15. Well, I'm not making this easy. 15 squared, 15 times 15, 5 15s, 75, 5 1s, 5 plus 7 is 125, and then we do 10 lots of 15, so that's going to be 0, 5, 1, so 50. Oh, sorry, let's try that again. Right. 5 lots of 5 is 25. 5 lots of 1 is 5 plus 2 is going to be 75. That makes a bit more sense. And then we do 10 lots of 5, so that's going to be 0. 10 lots of 5 is going to be 5. 10 lots of 1 is going to be 1, so that's going to be, if you add that together, 225. So we get 225 divided by 10. Take away 3 lots of 15, which is 45. So that's 22.5, take away 45. And 22.5, take away 45. That equals minus 22.5. So here, the coordinate is 15 minus 22.5. So therefore, the depth of the bowl is going to be 22.5 centimeters. Okay, so let's have a look at this one. We've got m as a starting point such that BMMC is 1 to 2. Now what this means is that if m is the point, so BM to MC is 1 to 2, that means that from B to M, and then M to C, that's going to be 1 part and 2 parts. So therefore, that whole journey is 3 parts. And then B to M is going to be 1/3 of B to C. So B to M is going to be 1/3 of B to C. So here's Chai's method to find B to M in terms of A and B. So B to C is going to be B to A, then A to C, and yeah, that's fair enough. To get from B to C, you go from B to A and then A to C. So that's going to be minus B then plus A. So yeah, that bit's right. Another way of writing minus B plus A is A minus B. So yeah, I'm happy enough with that. Right, now it says here that BM equals half of BC. Now, the fact that it's in the ratio 1 to 2 means this is one part and this is two parts. So evaluate Charlie's method down to A minus B I'm on board with, so is correct. However, B to M is 1/3 of BC, not 1/2. So, next question. Martin expands 2x plus 1, 2x minus 3, 3x plus 2. He gets this. Explain why Martin's solution cannot be correct. So they're not expecting you to do all of this, but there should be a way to see whether or not he's got it correct. So what I'd do is probably check out the 12x cubed first of all. So the way he's got 12x cubed is he's done 2x times 2x, and then he's times that by the 3x. So x times x times x is going to be x cubed. 2 times 2 is 4, times by 3 is going to be 12, yeah. So 12x cubed, yeah, he's got that bit right. Let's try out this plus 6 here. So the way he's got plus 6 is he's done 1 times by minus 3, which is minus 3, times by 2, which should be, so 1 times by minus 3 times by 2 equals minus 6. So, therefore, he isn't correct. And that's good enough for that, because 1 times minus 3 times 2 is minus 6. He isn't correct, as he wrote plus 6 instead. There you go, I reckon we covered our bases now. Next question. We've got to work out AOB. Let's have a look at this. We've got BDC. So B to D to C is going to be 57 degrees. Now, we've got alternate segment theorem here. And this is one thing that I just got to memorize, really. So if we've got this angle here, therefore the opposite angle in the triangle is also going to be 57 degrees. So that's going to be this one here. So this one here is 57 degrees. Now, the whole thing about triangles is that if we're going from the center, those are both going to be the same length. So therefore, they're going to be an isosceles triangle. So therefore, this one here is going to be 57 degrees. And notice I haven't even read the question yet, so I don't know what I've got to do. But this is stuff that I'll start writing down just so I get some marks. We're going to work out angle AOB, which is this one here. So we know that angles in a triangle add up to 180. So 57 plus 57 is going to be 114 degrees. We know that angles in a triangle add up to 180. So 180 take away 114 equals 66 degrees. Job done. However, we haven't got all 4 marks yet because, as is on most of these angle questions now, you must give a reason for each stage of your working. So, if this is 57 degrees, I would say that this one's 57 degrees because of alternate segment theory. In fact, no, it's not theory, it's a theorem, thinking about it, because it's been proved. Now, if this is 57 degrees, this will also be 57 degrees, as OA and OB, both the radius, or radiuses, radii, so both radii, therefore isosceles triangle. And then this one here is going to be 66 degrees, as angles in a triangle add to 180 degrees. Okie dokie. So the next question is a spiral question. So we've got to find the expression in terms of nth length of the nth side. So the diagram shows the first 10 sides of the spiral pattern. It also gives the length in centimeters of the first 5 sides. So we've got 1.5, we've got 3, we've got 5.5, we've got 9, we've got 13.5. So we can see that nth term, usually you see what the difference is each time, and you go up in that. But these aren't going up in the same amount each time. So for instance, this one's going up in 1.5 to start off with, then it's going up in 2.5, and then 3.5, and then 4.5. So it's not going up in the same amount each time. And so when it's not going up in the same amount each time, what we do is we have a look at what we call the second differences. So the first differences are 1.5, 2.5, 3.5, 4.5. The difference in the differences is 1, 1, 1. So what we do is whatever the difference in the differences is, or the second differences, if that is the same number, then what we do is we halve that and times it by n squared. So the first part of it is going to look like half n squared, and that's going to be the first part of the nth term. Then if we do that, so let's work out what half n squared is. So half of 1 squared is going to be 0.5. Half of 2 squared, so 2 squared is 4. Half of that is going to be 2. Half of 3, so 3 squared is going to be 9. Half of that is going to be 4.5. 5 squared is 25. Half of that is going to be 12.5. And then this is half n squared. And we can see the actual sequence is 1.53, 5.59, 13.5. So what we need to do to this half n squared is we need to add 1. Then it gets to our sequence here. So that's how to do n terms when it's not the same difference each time. So we have a look at the difference. Then if it's not the same, we have a look at the second difference. Whatever that second difference is, we halve it and then times it by n squared. So that gives us the half n squared. We then work out what half n squared is, and we compare that to our sequence. Next up is this one here. And we've got to prove that ABD is similar to triangle CBA. If we enlarge that a little bit. Okay, so similar. If something is mathematically similar, it means that it is an enlargement. So it means that ABD, so this big triangle here, is going to be enlarged from CBA, which is the smaller triangle here. So if they're going to be similar, then all 3 angles for the triangles need to be the same. So if we get rid of this, we can see that for ACB, it's going to be the same. So angle ACB is going to be the same as angle BAD, because they're both right angles. Therefore, they both share one angle. If we have a look at angle ABC, that's the same as angle ABD, because it is literally the same angle. So therefore, both the triangles have 2 angles the same. So now what we've got to do is we've got to work out angle CAB, and that's going to be 180 degrees. Take away 90, take away angle ABC. Now, that's going to be angle CAB. So now if we work out angle ADB, that's going to be 180 degrees. Take away the 90. Take away the same angle ABC. So therefore, angle ADB is the same as CAB. Therefore, all triangles, both triangles share the same three angles, therefore similar. Remember, similar just means not roughly the same as, it means one's an enlargement of the other one. Okie dokie. Question 20. Solve algebraically. Now what we've got here is we've got two equations that we've got to solve simultaneously, but one of them involves an x squared. So if one of them involves an x squared, we have a look at the second one, and you either get it as x equals or y equals. So it's easy to get x equals here, and what we're going to do is we're going to move this minus 2y onto the other side. So x equals 2y minus 3. And then once we've done that, we substitute it back into the first one. So instead of x squared, we're going to remove that and replace with 2y minus 3 squared plus y squared equals 18. Now, the most common mistake people do now is they just write that as 4y squared. So they square 2y and get 4y squared. They square minus 3 and get plus 9, and they just leave it like that. But if you have one bracket squared, you need to write the bracket out twice. So that's going to be 2y minus 3 times by 2y minus 3 plus y squared equals 18. And then whichever method you use, I use the smiley face method. We multiply this one out. So 2y times 2y is 4y squared. Minus 3 times minus 3 is going to be plus 9. Minus 3 times 2y is going to be minus 6y. 2y times minus 3 minus 6y plus y squared equals 18. Now what you do is you bring everything over to the left-hand side and you simplify it. So 4y squared plus y squared is going to be 5y squared. Minus 6y is going to be minus 12y. And we've got 9 minus 18, which is going to be minus 9 equals 0. And then what we're going to do is we're going to try and factorise that. So if we factorise that, something times something makes 5y squared, so that's going to be 5y times by y. And then we need to have something that multiplies together to make 9. And then the nodes in the mouth are going to make minus 12. So if we put 3 and 3 here, 3 times 3 is 9. And the nodes are going to be 3y. And the mouth, up here, is going to be 15y. So the way we use 3y and 15y to make minus 12y is we need to have minus 15y and plus 3y. So that's going to make it plus 3y. That's going to make it minus 3y. Now, once we've done that, we work out the solutions to both brackets. So the second bracket here, we're going to have y equals 0. The first bracket, we're going to make 5y plus 3 equals 0. So 5y equals minus 3, y equals minus 3 over 5. So those are our two solutions for y. But just like in all of the simultaneous equations questions, we now need to work out what our value of x is. And we know that x is 2 lots of y take away 3. So when y is 0, 2 lots of that take away 3 is going to be minus 3. This one we need to do 2 lots of minus 3/5. That's going to be minus 6/5. So x equals minus 6/5. There's 2 lots of 3/5 is going to be 6/5. And then take away 3. We can write minus 6/5 as minus 1 and 1/5. So minus 1 and 1/5 take away 3. X is going to be minus 4 and 1/5. And that's that. So that's question 20. And again, not an easy question. That's why it's towards the end of the paper. Next, we've got to show that this thing can be written like this. Now, we call this rationalising. That's where we've got a square root on the bottom. In maths, we don't like it when we've got a square root on the bottom. And the way we get around it is whatever is on the bottom, if we've got 5 plus the square root of something, we're going to times the top and bottom by whatever this is, but we just change the sign in the middle. So we're going to times top and bottom by 5 minus the square root of 8. And then we've got 2 sets of 2 brackets, so we're going to use the smiley face method. So 3 times 5 equals 15. Root 2 times, well, first of all it's going to be plus times a minus, that's going to be a minus. Root 2 times root 8 is going to be root 16. So that's going to be the square root of 16. Then we got plus 5 root 2. Then we got minus 3 root 8. Then on the bottom, if we do the same, we're going to have 5 times 5, which is 25. We're going to have root 8 times minus root 8, so that's going to be minus the square root of 64. And we've got plus 5 root 8. We've got minus 5 root 8. So if we deal with the bottom first of all, 5 root 8, take away 5 root 8, that just cancels out. The square root of 64 is going to be 8. So 25 take away 8 leaves us with 17. So we've got 17 on the bottom. So on the bottom we've got 17. And now we've got to deal with the top. So we've got 15 take away square root of 16. The square root of 16 is 4. So 15 take away 4 is going to be 11. So again, it's looking good. Then we've got this 5 root 2 take away 3 root 8. Now this 3 root 8 is the thing that's causing us some jip at the moment. So 3 root 8, we can say that root 8 is the same as the square root of 4 times the square root of 2. So the square root of 4 is 2. So 3 lots of 2 is 6. It's going to be 6 root 2. So we're going to have 11 plus 5 root 2 minus 6 root 2. 5 root 2 take away 6 root 2 is minus 1 root 2, which is what they got there. So it's going to be 11 minus 1 root 2, which is minus root 2, over 17, and that's the final answer. Okay, so graph A is a reflection of the graph y equals f of x. Write down the equation of the graph A. So what's happened, it's been reflected in the y-axis. Now whenever anything moves left and right in graphs, we're looking at inside the brackets. And if it's been reflected in the y-axis, we write it as y equals f to the minus x. So when there's a minus sign, it means it's been reflected. If the minus is on the outside, it means it's been reflected in the x-axis. So if it's inside the brackets, it means it's been reflected in the y-axis. So just a quick mark for that one. Next one. We've got y equals g of x, which is shown on the grid, which is this one here. Write down the equation of graph B. So what's happened is it's been moved up by 1. So that's going to be y equals g of x plus 1. And remember that the reason that it's plus 1 outside the brackets is because it's been moved up. Inside the brackets, left and right. Outside the brackets, up and down. Okay, so now it's y equals cos of x, and this one is just being familiar with the cos graph. So the cos graph goes from 1 down to minus 1. So I know that here, the bottom part is minus 1, so the y coordinate is minus 1. And the other thing, with the cos graph, it goes 90, 180, 270, and 360. Minus 90, minus 180, minus 270, and minus 360. I mean, there's no real understanding to this, it's just being aware of the graph. And so the coordinate C is 180 across and then 1 down. So that's going to be 180 minus 1. Okay, next question is a histogram question. We've got to work out the probability that the member is more than 30 years old. So we're told that there's 20 members between 25 and 30. So frequency, the key thing with histograms, and this is worth noting, histograms, the frequency equals the area of the bar. Again, worth knowing that inside and out. So they're telling you that the bar between 25 and 30, this one here, the frequency is 20. So therefore the area of this bar here is 20. So the width between 25 and 30 is 5. So that there is a width of 5. So therefore if the area is 20, the height must be 4. So therefore this is 4. So we can break our graph down, which isn't easy to see. That's 2, 3, 1, 0. So now what we're going to do is, if we were to work out the probability that the member is more than 30 years old, we've got to work out how many are more than 30 and do that out of the total of however many there are. So if we have a look here, this has got a width of 30. If it's gone up to 1, that's 0.1, 0.2, 0.3. That's going to be 30. This bar here is 30 times by 0.3, which is 9. So there are 9 people between 50 and 80. Now the width of this bar is 20, and it's gone up to 2.9, 2.8, 2.7, 2.6. So that's 20 times by 2.6 for this bar. Now 10 times 2.6 is 26, so 20 times 2.6 is 52. So in terms of over the age of 30, there's 52 and 9. There are 61 over the age of 30. Okay, let's have a look at the other bars. So in between 0 and 10, that's a width of 10. And that's gone up to 0.9, 0.8, 0.7. So that's 10 times 0.7, so that's going to be 7. This here is in between 10 and 25, so that's a width of 15. And the height is 2. So 15 times 2 is 30. So now what we can do is we can add up all these numbers. That's however many people there are in total in this football supporters club. So those two added up to 61. That's going to be plus 81. Plus 30. 81 plus 30 is going to be 111 and 118. So it's 61 out of 118. And that's a probability. Remember, probability is just however many you want out of however many there are in total. And the key thing to this question is knowing that the frequency is the area of the bar. So if we know the area of this first bar here is 20, and you know the width is 5 in between 25 and 30, the height must be 4. And once you've done that, you can write out the y-axis. And once you've done that, the histogram questions tend to answer themselves. Okay, now we have got our final question. Exciting times. Right, now the final question, immediately it looks to me like a tree diagram question. Now the reason that I think it's a tree diagram question, it says it's probability. So probability towards the back end of a paper, other than the fact the last one's probability, that was a histogram. It's a probability question, and we've got counters in a bag. And we've got bag A, bag B, and bag C. So what we've got here is, first of all, probability there are now more black counters than white counters in bag C. Let's try and work this out. So he takes a random counter from bag A. So we've got bag A, and it's either going to be black or white. Now the probability that there's a black counter in bag A is going to be 6 out of 10 and 4 out of 10 for that one. I don't usually simplify these probabilities down. And then we've got bag B. So what we've got here, Bernie takes that random counter from bag A and puts into bag B. So let's say we come down this road here, the one that I've just drawn. We've got black and white. Now, if we've gone down this road, it means that he's taken a black counter out first of all. So now there's going to be 8 black counters in there. So that's going to be 8 out of now 11. And there's going to be 3 out of 11 white counters. However, if you took a white counter out first of all, then there's going to be 6 black counters. That's right. Yeah, it's going to be 7, because we're talking about bag B. 7 black counters out of 11, and there's going to be 4 white counters, because in bag B there was 7 and 3 originally. However, if we've taken out another white counter, there's now going to be 4 in there. Sorry for switching colours. And then bag C. Now originally there are 5 black counters in and 5 white counters. However, if we have taken a black counter out of bag B, we are now going to have 6 out of 11 in bag B, and there's only going to be 5 out of 11 of that one. Okay, so carrying on, if we've gone down this road here, we've got a white counter in, so black and white, so therefore we'll have 6 elevenths, and this one will be 5 elevenths. So this was black, this was white, so this one here, therefore this one is going to, you're going to have 6 elevenths in there, and this one's going to be 5 elevenths. And this one here, black and white, is going to be 6 elevenths and then 5 elevenths. So the branches that lead us to having more blacks than whites in bag C is going to be this one. Oh, no, sorry, I got placed around the wrong way. That was 6 over 11, that was 5 over 11. So the ones that are once with more black counters than white counters are going to be this one, this one, this one, this one, which is this branch here and this branch here. The one where there's more white counters in is going to be this one here and this one here. So the branches that we want, we can get rid of this last set here. So it's going to be this branch here, so that's going to be 6 tenths times by 8 elevenths, and this one here is 4 tenths times by 7 elevenths. So 6 times 8 is going to be 48 over 110. This one here is going to be 28 over 110. And if you add those two together, that's going to be 76 out of 110. It never says on these questions to simplify your answer, so that is the final answer. Well done, and well done for getting through the video, and best of luck with